Hey everybody, today we're going to be going over our intro to statics. We're going to go over Newton's laws. So the first law, the law of inertia, it pretty much says an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. So what does that mean? Imagine we have a little particle and it's moving in a vacuum, just traveling through space. It'll keep going forever until, for example, you hit a wall. Let's imagine this is a wall right here. Then boom, the uh, the particle will stop moving because of the wall. And then this is pretty much sums up the inertia. All it's saying is that this particle here will keep going forever until it hits another force, another external force outside of that particle. In this case, the wall. Another scenario we can think about is imagine an apple. So an apple falling, an apple. I don't know if you guys know the story, but that's how Newton kind of came up with this idea. At least that's how the story goes. So imagine you have this little apple here falling down from a tree. And the law of inertia is saying that this apple here is going to keep falling to the ground. There's a tree right here. A tree, apple tree. And once the apple falls, it's going to keep falling down all the way until it hits the ground. Basically, the law of inertia says that the object will keep moving in any direction unless acted by a specific force, by a specific external force. And once it stops moving, then it won't go anywhere unless it's acted upon by another force. That's basically what it says. So pretty much it basically means that the object keeps moving in uniform motion unless acted upon by an external force. Very simple. The second law is basically summed up by F equals mass times acceleration. F equals ma. You probably guys have heard this before. M represents mass, A represents acceleration, and once you multiply your mass times acceleration, it'll give you a force unit. For example, if you have 1 kilogram ball here, 1 kg ball, moving, I should say accelerating at 1 meter per second squared. 1 meter per second squared. So this 1 kg ball is accelerating at 1 meter per second squared. It'll result in 1 Newton of force. Newton of force. And why is it called a Newton? I don't know, but I'm thinking it's because they're Newton's laws. So that's probably why. I'm not really sure, but that's what we call it. 1 kilogram accelerating at 1 meter per second squared is called 1 Newton. I don't know if you, and that sums up the second law. Now for the third law. The third law. Third law pretty much states for every action, there is an equal or opposite reaction. So basically what it's saying is, imagine in our little apple diagram here, and you have the ground here. This is the ground, this is the apple, little apple. So basically, I don't know if you guys are familiar with the gravity. So the Earth has a gravity pull. Okay, so in Earth we have this gravity constant of acceleration, which is 9.81 meters per second squared. So the apple is falling. Pretty much it's saying that the force created by this apple, by the weight of the apple times the acceleration of gravity due to gravity, it's going to give you a force. So let's say the apple is 0.1 kgs. 0.1 kg apple is our mass, and our acceleration in this case, it's equal to g, which is 9.81 meter per second squared. 9.81 meter per second squared. So so this is our mass in this case, the 0.1 kg for the apple, and the acceleration due to gravity, which is usually simplified as g, is 9.81 meter per second squared. So this apple, when it's falling down, it's creating a force of on the ground of, what is that? 0.1 times 9.81. It's about let's just say 0.981 newtons of force on the ground. So that means that in order for the apple to remain, okay, so pretty much what this third law is saying is that the ground is creating an equal and opposite reaction. So like this. So the apple has a force going this way because of the gravity towards the earth, and then the ground will push up against that to create an equal and opposite reaction. So that means the floor will create a 0.981 newtons force to keep it balanced. That's basically what the third law says. Now let's talk about the types of motion. So we have basically two types of motion. One is translation, and the other one is, I forgot what it's called, but I think we call it rotation. Give me a second. Let me look at my notes. Yeah, we call it rotation. So basically what translation is you have this particle, and then you can move in the, let's call it x direction, right? Just for the sake of notation. And y direction, right? So it could translate either in the x direction or y direction. And also, in rotation, this particle can spin, can create a rotation, something like this. Like imagine, pretty much it's spinning this way, like spinning. So that's what rotation is. So these are basically our two types of motion: translation and rotation. And all we're trying to do in statics, since the word statics means it's not moving, therefore, all we're trying to do in statics is have all of our forces in the x direction, the sum of the forces in the x direction be equal to 0, and the sum of the forces in the y direction equal to 0 as well. And our spin, let's call it, we call it moment about this point, moment about the point equal to 0. I should say the sum of the moments about this point equal to 0. That's basically what we're trying to do in statics, is trying to ensure if something is not moving, then that means all the forces need to be equal. If we go back to this, when the apple is on the ground here, it's exerting 0.981 newtons of force on the ground, and the equal and opposite reaction from the ground to the apple is 0.981 newtons as well. So in our little example, let's call it the y direction, right? We'll call it x-axis and y-axis. All we're saying is that if we take this force plus this, let's say force of the apple going down, force of the apple going down, plus force of the apple, force of the ground, no, let's call it floor, the force of the floor, which is this one right here, going up, and the force of the apple here. in order for this to not move, and so we could have this case where the apple is not moving up or down, this is our equation. That's all we're saying. Some of the forces here, some of the forces in the y direction. So if we do our little math here, we can say, okay, FA, what does FA equal? 0.91 newtons, right? But notice that it's pointing down. So in order to make it down, this needs to equal 0, by the way. Okay, so since we have a little arrow pointing down, we can call that a negative. Generally speaking, we call going up positive and then down negative. That's usually our convention when we're doing things, but it's really arbitrary, and you could use whatever convention you like. Okay, so in this case, let's just assume FA is going down. Okay, so FA is going down, so that's negative because it's going down. Remember, here, this translates to here, negative 0.981 newtons, plus, because it's going up, right? Our little force is going up, plus 0.981 newtons from the floor, right? This is here. This is getting too messy. Okay. Basically, you have negative 0.981 plus 0.981 equals 0. And then that's how we can verify, check mark, that this is true. And that in fact, we basically just prove Newton's law. If an object is not moving, then the force is equal 0. Once you add up the forces in the y, for example, in this case, then they equal 0. And just to make a little note, in this case, we have no forces moving in the vertical direction. I'm sorry, in the horizontal direction. So there's no forces in the x, right? There's no force being applied on the x direction on this little apple. There's no force here, and there's no rotation, no spin. There's no external spin on the apple. So that's why we just assume there's 0 in this case. So that's basically what we try to do in statics. We try to look at free body diagrams, basically we try to look at free body diagrams and then try to find the reactions and other types of, we pretty much use this knowledge that we have from statics, saying that all the forces and the moments will be equal 0 to determine our problems. So that was a very brief introduction to this statics, and I'll see you in the next one.